In the world of AI, it feels like we're in this constant high-speed chase for the next big thing, right? We're kind of programmed to think that newer, bigger, and more complex has to be better. But what if I told you the grizzled veteran, the one that's been in the corner all this time, still has the winning moves? So that's the big question we're going to dig into. You see this everywhere in AI, but it's especially critical in a field like medical imaging, where, let's be honest, pinpoint accuracy can literally be a matter of life and death. I mean, the hype cycle is it's relentless. One month, it's all about transformers. The next, it's some new thing called a Mamba model. And each one shows up with a stack of research papers claiming it's the new king of the hill, promising to spot tumors or other anomalies in medical scans better than anything we've ever seen. But is that really the whole story? To really get this story, you gotta meet our main character. And surprisingly, it's not some flashy newcomer. It's a quiet, established champion that's been kind of dominating the scene for years. Say hello to nnUNET. The name itself is a dead giveaway. No new net. Its whole philosophy, right from when it came out way back in 2018, was pretty radical. It basically said, hey, instead of chasing after shiny new architectures, what if the real secret to amazing performance is just mastering the fundamentals? And this quote from their original paper just nails it. The creators were arguing that all the boring stuff, like how you prep the data, how you train the model, your whole strategy, is actually more important than the design of the network itself. It wasn't about building a brand new car. It was about being the best damn mechanic in the world. So how does it pull this off? Well, think of UNET as this hyper-intelligent, automated pit crew. Instead of designing a new car for every single race, it meticulously analyzes the racetrack. That's our data set. And then it perfectly tunes every single part of a standard race car to be perfect for that specific track. It's a system that's built to make a standard model perform at its absolute peak every single time, no matter the challenge. But you know how these stories go, right? The reliable, hardworking champion is never quite as exciting as the hotshot challenger. And pretty soon, a whole new class of models showed up, promising to leave the old guard completely in the dust. These were models like Transformers and Mamba, and they came over from the world of language processing. The big selling point was this. While the old school networks, the CNNs, were great at seeing tiny local details, these new models could supposedly see the big picture, the entire context of an image at once. And theoretically, that should make them way, way better. And suddenly, you started seeing papers pop up with headlines just like this one. They all showed these new transformer-based models wiping the floor with the old UNET baselines. The evidence seemed overwhelming. The new blood was here, and the old champion's reign had to be over. Okay, but here's where the plot thickens. A 2024 study decided to take a much closer look at these so-called races and started asking some really tough questions about how the competition was being run. And that's the million-dollar question, isn't it? When these new, shiny models were claiming victory, were they actually competing on a level playing field? Well, as the researchers found out, the answer was often a big, fat no. This 2024 paper identified exactly what was going on, and they called them validation pitfalls. In a nutshell, the new models weren't really racing against the champion. They were racing against a poorly configured, out-of-shape version of the champion. It's like a race car with flat tires. Many of these studies gave the new models hidden advantages or just used different rules. The race, it turns out, was often rigged from the start, even if nobody meant for it to be. So what do? Well, you organize a rematch, a fair one. These researchers decided to settle the score once and for all. They set up a massive, comprehensive benchmark where every single model, new and old, had to play by the exact same rules. And the idea was super simple, but absolutely critical. Level the playing field. Every model, the old CNNs, the flashy transformers, the new Mamba approaches, got the same amount of computer power, the same data, and was run through the same standardized system. It was a true apples-to-apples comparison. No more hidden advantages, no more weak baselines. And the results? Well, they were absolutely stunning. When all the dust settled, the winner wasn't the flashy new technology. The best, most consistent performance came from those well-configured CNN-based UNET models, the exact same architecture that nnUNET had perfected years ago. The old champion, when put into a fair fight, was still the undisputed king. Just let that sink in for a second. The winning approach wasn't developed last month or even last year. It was introduced all the way back in 2018. In the lightning-fast world of AI, that is an eternity. And it proves a really powerful point. Progress isn't always about reinventing the wheel. Okay, so what's the real takeaway here? Because this isn't just about one algorithm being better than another. No, it's about a much bigger, much more important lesson for the entire field of AI research. It comes down to this thing the researchers call innovation bias, and it's basically our collective obsession with what's new. The scientific community, the journals, the conferences, they often reward the new and novel much more than the rigorous. It's just more exciting to publish a paper about a brand new architecture than one that carefully validates an old one, even if that old one done right is actually better. And this final quote from the paper really brings it all home. It's a call to action. It's saying that for us to actually make real, lasting progress, we have to start valuing good, solid science, the hard work of rigorous testing and fair comparisons, just as much as we value shiny new ideas. So it leaves us all with this one last really important question to think about. This story of an underdog algorithm is a powerful reminder that true innovation isn't always about the next big, flashy breakthrough. Sometimes it's about the discipline and quiet mastery of what we already have.